Hey guys, welcome to day 88 of Codeforces Every Day Until GM. Still a little bit sick, so sorry if I'm coughing a lot. Just didn't want to go too long without creating videos. Let's just jump straight into it. I did really want to lock in Codeforces this summer because the grind just doesn't stop. There's a contest tomorrow. I'll try to wake up and do it and hopefully do a recording on it. But yeah. I need to be more proactive if I want to get better at this, so that's what I'm going to try to do. Oh yeah, I guess while I'm yapping, make sure to like, subscribe. We are very close to 500 subscribers. I'll be very happy if we can hit that. And if y'all want to, join the Discord down below. We just yap about questions down there. I post a problem of the day and solve it. This is going to be tomorrow's problem of the day, so that's why it's up here. But let's solve it first before anything. Alright, Kifa in Park. Kifa decided to celebrate his first big salary by going to a restaurant. He lives by an unusual park. The park is a rooted tree consisting of N vertices with the root at vertex 1. Vertex 1 also contains Kifa's house. Unfortunately for our hero, the park contains cats. Kifa has already found out what are the vertices with cats in them. The leaf vertices of the park contain restaurants. Kiva wants to choose a restaurant where he will go, but unfortunately he is very afraid of cats, so there is no way he will go to the restaurant if the path from the restaurant to his house contains more than m consecutive vertices with cats. Your task is to help Kiva count the number of restaurants where he can go. So this guy hates cats, but I love cats, so I don't know. Let's figure this out. So consecutive vertices, that's the key thing here, right? It's not total. Good thing to notice. Given two integers, nm equals map int input split. Okay. And this is just very clearly a DFS question, right? Because the given graph is a tree, right? Leaf vertices. I guess you can't really assume it, but the tag is trees, so. And with leaf nodes are like these things, right? So okay, so some of these will be colored, right? And we kind of just count how many colored there are, and if it's greater than, like, okay, we DFS, we traverse, and then we traverse, and then we traverse, and then we traverse, right? And we just count how many colored there are for each branch, and it's basically how many bottom nodes there are minus how many colored branches that are like greater than m, right? Which in this case, let's say m is, oh, it's consecutive though, so it's not that simple. So it's like we need to set some sort of reset condition, like we need to track a consecutive video or a consecutive variable, and then it's like const, you have to plus equals 1 every single time they're adjacent, and if they're not adjacent, we set const to 0 again. So okay, I don't actually know how to build like a tree. Like I wouldn't say never done it. Like I took a data structures class, but they didn't really teach it very well. but I'm pretty sure I can just reuse like a few videos ago. I don't know. It may be that one question that I recorded a video on, but like forgot to click record. So maybe y'all didn't see this one, but I did a graph question with edges where basically you just took in, like they give you the the connections, right? These are two vertices, and saying 1 and 2 have a connection. Yeah. So can't we just use like an adjacency matrix, and but like we have the knowledge that it is uh, a a tree of some sort, right? It doesn't look like there's any cycles or it's like a graph or anything. It's just kind of a tree because there's a path. Yeah, it is a tree specifically. So I guess we can define add edge. We take in our adjacency matrix I and j, and then we just do add I dot append j and add j dot append I. A equals list map into input split. And then we create our adjacency list. This for in range in +1, because the first node starts at 1, so the first thing in the adjacency list should be an empty, and then we start. It should look like this. Yeah, and these will be full. This one will always be empty because we will just not use it, which is why we need n +1. And then m in second line contains n integers. Okay, so n is the number of vertices we'll have. So for I in range n, u v equals map into input split. No, I've always defined this as like with the snake case, but I use Pascal case more anyway, so might as well make that change here. UV, and then we simply just add edge, call add edge with edge, and then pass in UV. There we go. And then, okay, what do we do from here? So this should create an adjacency list. Shown. End of file and reading line. 15. 4, 1, 2. Oh, I guess it starts at 0, right? Do n -1. Okay, yeah, so skips 1, and then 1 is connected to 2, 3, 4, and then 2 is connected to 1, 3 is connected to 1, 4 is connected to 1. Yeah, this should be correct. And check for this one. Skips this one, and then 2 connected to 1, 3 is connected to 1, and then 2 is connected to 1, 4, 5, 3 is connected to 1, 6, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, Yeah, 4 is connected to 2, 5 is only connected to 2, 6 is only connected to 3, 7 is only connected to 3. Alright. So now, track our toPrint variable. And we need to create some sort of modified DFS here, right? So def DFS. DFS should track our current node, our parent node, and then let's do this for now. Global toPrint. Set this as a global variable, which usually isn't good, but I think it'll work for this. So we want to skip our parent node. No, so we can just do for I in edge current node, and then check if I is equal to our parent. Okay, this question, the entire setup for this question feels similar to. If y'all are in the Discord, y'all would know which question I'm talking about, but I don't remember what it's called. Some 1400 rated graph problem that used like bipartite graphs or something. This one isn't like exactly bipartite graphs, but the setup is exactly the same. Like all this is exactly the same. Just DFS. I've never actually coded DFS before, but in theory it should just be like for every adjacent value you just call DFS again unless it's equal to parent. So if I is equal to parent, if I is not equal to parent, we just call DFS again, and then we pass in the node and parent. This should just be it, right? If I print our current node here. Start from node 1, no parent. Yeah. This should print out all the nodes. It's Jover. Wait, when does this print out? This is wrong. This is I, and this is node. Yeah, I was just passing the same thing into it. So. Okay, I literally am better from my whatever sickness I caught, but gosh, my throat is still killing me. I sounded like a horse yesterday. That's why I didn't want to make any videos. But hopefully I sound a little better today. My voice is a little crackled, but hopefully it's still an enjoyable listen for y'all. Okay. So 1, 2, 3, 4. 1, 2, 3, 4. I printed out all the nodes. So this one should print 1, 2, 4, 5, 3, 6, 7. 1, 2, 4, 5, 3, 6, 7. Okay. Perfect. So now I need to somehow keep track of the coloring. Need some sort of reset where it's it's like if if a node minus 1, because start at 1, is equal to 0, we want to set consecutive to 0. If it's 1, we just want a plus equals 1. We do something like else const plus equals 1. Just pass it in here. 0. And then if const is greater than m, return. So returned. So this is no good. 0 consecutive 0. Okay, this seems to be working. And for this one, 1 consecutive, which is fine. 0 consecutive, which is good. 1, wait. Why is this 1, 0, 1, 0, 2 returned? Uh, should be 4 output. There's 5 outputs? I guess it should double output, right? Wait, I'm so confused. What's going on here? One, one. We're at node 2. 0. Okay. Node 4, 1. So this is all one branch, which means it's good. And then 5 return. But then it never gets to these. Why does it never get to these? Wait, if I didn't have this, would it get to these? It does. So why? Now it stops at. Const is greater than m. To return. Shouldn't we be calling the next DFS? If it's 2, we don't even go to this one. Is that what's happening? Because since we return early, we never hit this, which means we'll never get to 6, 7. This just... Okay, I think this is expected behavior. I think. So now we need to track. We need to figure out if it's the end of the tree, which means it's the end of the tree if it only has one connection, and it only connects to its parent. Yes, what is the minimum in... So there's at least 2 nodes, which means the minimum case is this. Alright. So we can check if the length of this is 1. Ugh. Where's... Okay, node. Jeez. If lane node equals 1 to print plus equals 1, return. Print to print. Print is an integer. Okay, that question wasn't that bad. Alright, there's no edge cases to be aware of. Like a lot of this was just like stuff you can steal from other questions. Like all of this I've coded like all of this maybe like two, 3 times already by now. I could probably like, oh yeah, look at this. Bang. Where's the other one? Bang. This question was from a contest my university's club did. And it was like basically the solve was basically the exact same as this one Codeforces problem. Where look at this. Add edge, import, create the adjacency list, add the edges. This one. Define add edge, take in the imports, create the adjacency list, add edges. And the funny thing was, for both of these, it's both bipartite graphs. So we have this color variable, 2-parent variable, and then all of this code is basically the same. The only difference is what we actually do in the final like check loop. This one isn't bipartite graph; it's trees. But like we could reuse like the adjacency list, which made it very easy. Like I wonder like what the actual way to build like I guess build a tree is. I know there's like binary trees where you would like define and then you'd have like nodes. I guess we could geeks for geeks it. Let's see. Tree. I mean, this isn't exactly a binary tree, right? It's just like a generic tree. Binary tree. Yeah, left to right, and it would be you define a class node self.left, self.right, self.val is key. First node, initialize the nodes. Okay, this seems very annoying and unintuitive. But yeah, there's all sorts of trees, right? Like, geez, like, know about binary trees. Binary search trees, AVL trees. Red black. This isn't a red black tree. This is a generic tree, right? Yeah, something like this. Oh, this looks cancer. Unknown number of children. Yeah, like how do you... I guess self.children is an array. Interesting. Okay. I do plan on like doing a deep dive into data structures this summer as well. I'm gonna go through the NeetCode roadmap as a video series on top of Codeforces every day until GM. And then I need to get back into the CSES stuff, but I might do the NeetCode stuff first, just because that actually teaches me stuff. It teaches me the building blocks that I need to use for CSES. Like it's hard doing DFS when you don't really like I've learned it before, but it's been a while and I've never actually coded it in Python. I think when I learned it, I was using C++. Anyway, but like DFS is pretty intuitive. It's literally just like a for loop through the adjacency list. Like, how do you normally do DFS? DFS. Have I even submitted this yet? Let's do that. While we do that, we can look into stuff. I thought I was just waiting for the submission. It turns out it wasn't. Wrong answer. It's not even correct, Drover. DFS for graph. This is for a graph. It might have a loop. If not visited. Yeah, you just track some visited state, right? It's kind of similar. If not parent. Instead of parent, you would have like a visited array, and then set that to true. Yeah. DFS isn't that bad. Okay, like what's wrong about this? Because this, like, it's probably some edge case. This feels like it should work. Output 1, answer is 0. One, 2, 2, 3. So it's like this. And then all these are value 1. So it should just be 0. Why is it not 0? We are allowed 2. Const is 0. Somehow we get into here? We do get into here. How do we get into here? So this right here. The only thing that connects to 1 is 2. This is not right. Because this is the root node. Oh, can't do this. We have to check in here if, like, after, we have to do it after the DFS instead of before it, because then we have scenarios where it can be like this. Okay, wait, that actually makes sense. It's also not that bad. I can probably, we need to check if our current node is a leaf node. If it is, then it's a leaf node. So we DFS off this, we get to here. We call DFS. DFS. Get to here. Before we call DFS, we never end up calling DFS on this. So we should just do leaf equals true. If one of the adjacencies is not the parent, then it's not a leaf node. And it can keep going, so leaf equals false. Otherwise, it is a leaf node. So if we're able to call DFS, it's not a leaf node. If we're not able to call for DFS, it is. So now we just check if leaf to int plus equals 1. Let's add this here, here, here. Oh, I don't know why a wave of nausea just hit me. I don't know what kind of weird sickness I have, but it's been like fever for 2 days, then like a day on the toilet. Thought I was better, and then like now my throat hurts and oh frick, bro, so weird. Need some water. Well, I was gonna try to record like longer video today, just because I haven't posted in a little while. Maybe I just sit on this question. I'm not feeling so good. Okay, I'll get this question and we'll see how. That's the wrong answer. God damn it. We'll see how I feel after. But did I run these? Oh, I did. It's because I have a random print statement somewhere, right? This should work. Yeah. Logically, this makes sense. Oh my god. Runtime error. That's 35. This is a language diff. Do I pull out the C++ for this question? Wait, it's a runtime error. It's not TLE. Runtime error on test 35? What the hell? Wait, so there's just something wrong with my code. It's not TLE. Where is this new C++ thing that I generated? Alright. It's a runtime error. Okay, it doesn't tell me the specifics. What would cause a runtime error? Runtime 256 megabytes. We used 18404 kV, which is 18 megabytes. Shouldn't have ran out of storage. Runtime was 203 ms, which is like way smaller than 2 seconds. Right, it's like 0.2 seconds. It's something wrong with computation? Runtime error. Oh, it's probably recursion limits, right? Python does have a recursion limit, which means I should try to do this iteratively. Okay. How do I implement the DFS iteratively? Find a stack. Dot hop. Stack.pop. Okay, so our value in our stack should be. Can't we just? I kind of get it. The value in our stack. Also, they did not need to do this. They could have just put it in here, like this. For me, it would be 1, -1, 1, because this is our first node, or 0, right? This is these, which is our parameters. This is our current node, its parent, and its value, its const, consecutive, const, whatever. And then while stack, we can just define these to be stack.pop. And then copy all this. Instead of return, use continue. And then stack.append. Should add it to the array, and then we pop it again. And then whenever we can. This should be it. Not that much of a difference. Should still have this. It's over. Let's stop append. Need to make this a array. Bang. Okay, this should work. Yeah, there we go. We got it. Alright. A 45-minute video, 1500 rated. It is an old 1500 rated, and it is a graph problems, so it's probably overrated in the first place. I was gonna do more questions in this video, but I think I'm just gonna call it here. If y'all enjoyed this video, be sure to like and subscribe. If there's any questions on this question, I think it was a pretty straightforward question. If y'all have any questions though, leave a comment. I'll try to respond to it. Join the Discord. I'll love to talk to y'all there. Um, yeah, I'll see y'all next time. Bye.